Oi! Well, that's the way we say hello in Brazil. Hello, children. How are you people doing? I'm Saurabh and I'm here to teach you people a little bit of mathematics. Now, children, today we are going to look up combinations in this lecture. We will learn to differentiate between permutations and combinations and also do a simple and a little higher level sum. Now, children, if you talk about this YouTube channel, the Mathematics Helpline, it also has an app related with it, which obviously contains content which is very beneficial to it. So make sure you go to the Play Store and download this app, the Mathematics Helpline, all in block letters, and I'm sure that is going to be very useful to you people. Now, children, we'll continue the lecture on combinations here. So whenever we talk about combinations, remember that we are not interested in the order of the objects which has been given to us, right? However, in permutations, contrary to this, the order of the objects is very important. Permutations are also referred to as arrangements, and when we talk about combinations, combinations are referred to as selections also. Now, when we talk about combinations, let's say we have some n objects and we want to find out the combination which can be formed out of, say, r objects taken at a time, then this is given by the notation something like this. That is, you have n, c, r, where this can be written as factorial n divided by n minus r factorial times of r factorial. Right? To have an example, let us consider that we have some 10c4. So we can write this as 10 factorial divided by 10 minus 4 factorial times of factorial 4. Right? So further, this can be written as factorial 10 divided by factorial 6 times of factorial 4. Right? And if you talk about a factorial, do remember, like if we talk about factorial 6, then that will mean 6 into 5 into 4 into 3 into 2 into 1. That means whosoever's factorial you try to find out, you will start writing from that number and multiply by all the other numbers up to the first natural number, right? Detail of all of this has been provided to you in the last lecture, where we have discussed about the combination notation very much in detail, and if there are sums which are possible on the notation of combination, then they also have been discussed there. So make sure to look up the last lecture. Now, children, we will be discussing about combinations. So let's quickly look up a simple sum where we will try and understand, whenever we have a sum on combination, what exactly do we do to solve the sum. Now here, children, in the question you've been given here that there is a group of 3 books in economics, 4 books in political science, then you have 5 books on geography. How many collections can be made if each collection consists of 2 books on each subject? Now here, children, remember that collection is another synonym of combination, and in collection obviously the order won't be important, right? So here, as such, as each collection is to have 2 books on each subject, so we will now be choosing 3 books from 3 books of economics, 2 books on economics, from 4 books of political science, 2 books on political science, and from 5 books of geography we will be selecting 2 books of geography, right? And then we will try and find out how many such collections are possible. So obviously here, in every collection, what we can do is we can now talk about from 3 books, right, which are there on economics, right? And then we will talk about from 4 books of political science, we've got to choose 2, and then from 5 books on geography, we've got to choose 2. So obviously, if we talk about a choice here, the books of economics can be chosen in 3C2 ways. The books of political science, 2 taken out of 4 books, can be selected in 4C2 ways, and from 5 books of geography we can select 2 books as 5C2 ways. Now, as here we will be talking about once a set of 2 books of economics taken, another set of 2 books of political science taken and another set of 2 books of geography taken, which can correspond to each other. So here we'll be talking about the principle of multiplication, and as such we will put up a multiplication sign which will show that each group is going to correspond to the other, so that we have multiple such groups which are possible. So if, say, we talk about some group of books of geography, some books of political science, and some group of books of economics which are there, which, say, can be said to be some M, N, and say P. So then if we talk about multiplication of M, N, and P, so then this is going to give you the total number of combinations which are possible, because each of these groups are then going to correspond with each other, as we've learned earlier in the principle of multiplication. Do look up the earlier lecture which was there in before permutations, where you will get a clear idea about what we mean by the principle of multiplication. Now children, we will be calculating all of this and get to our final answer. So further what we do is we can talk about 3c2 as factorial 3 divided by 3 minus 2 factorial times of factorial 2, which is now going to be multiplied by factorial 4 divided by 4 minus 2 factorial times of factorial 2, which is further going to be multiplied by factorial 5 divided by 5 minus 2 factorial times of factorial 2. Now next here what we do is we can further solve this as factorial 3, which is going to be divided by factorial 1, further to be divided by factorial 2, and this is going to be further written as factorial 4 divided by factorial 2 into factorial 2, and further to be multiplied by factorial 5 and divided by factorial 3 into factorial 2. Right now children, if we talk about factorial 3 here, so we can write this as 3 times of factorial 2, right? And in the denominator, if you talk about factorial 1, it will remain to be 1, as 1 is multiplicative identity, so we can forget it, right? And here in the denominator we have factorial 2, and further this is to be multiplied with factorial 4, which can then be written as 4 into 3 into factorial 2, and then we have a factorial 2 in the denominator, and factorial 2 is obviously 2 into 1, which can just be written as 2. Then we talk about factorial 5, which can again be written as 5 into 4 into factorial 3, and in the denominator we have factorial 3, which is going to be multiplied by 2 into 1, which is factorial 2, or it can be written to be 2, as 1 is multiplicative identity. Now children, what we do is we will cancel off the common factors like factorial 2 factorial 2 factorial 2 factorial 2 and factorial 3 factorial 3. Further then we talk about 2 cancelling 4 2 times, and then 2 cancelling 4 2 times, and then we will write the product as the final answer. So this comes to 3, which is going to be multiplied with 6, which is further to be multiplied with 10, and this children is going to give us the total number of combinations which are possible, and that comes to 180 such selections or combinations. Now I'll quickly discuss all of this all over again. In the question children, we've been given that there are a group of few books, 3 books on economics, 4 books on political science, 5 books on geography, and you've got to make collections, or you've got to make combinations of 2 books from each subject. So such groups of 6 books, each containing 2 of every subject, are to be formed, and how many such combinations or collections are possible is what we've got to try and find out. So here we first write the number of books that we have, that is 3 of economics, 4 of political science, 5 of geography. Then from the books of economics, what we do is we can choose 2 books as 3c2. Then we can choose 4 books as 4c2 of political science, and then from the 5 books of geography we can choose 2 books as 5c2 ways, as here order is not important. If order would have been important, then in place of C you would have talked about P, that is permutations. Now here children, by the notation we can write this as factorial 3 divided by factorial 3 minus 2 times of factorial 2. Now this is to be further multiplied with factorial 4, which is the number in the superfix, divided by the difference of the numbers in the superfix and the suffix factorial, that is 4 minus 2 factorial, multiplied further in the denominator by factorial of the suffix, that is factorial 2. Now further, this is to be multiplied with factorial 5 divided by factorial of the superfix and the suffix, that is 5 minus 2, and in the denominator we also have factorial of 2 here. Now children, next what we get to see is we can write here this factorial 3 as 3 into factorial 2. So factorial 2 will get cancelled. Similarly, factorial 4 can be written as 4 into 3 into factorial 2. So factorial 2 will get cancelled from the numerator and from the denominator. And further, in the last term, you will have here factorial 5 to be written as 5 into 4 into factorial 3. So factorial 3 will get cancelled. 2 cancels 4 2 times. 5 into 2 is 10, and then here we have 2 cancelling for 2 times. 2 into 3 is 6. 6 into 10 is 60. Into 3 will become equal to 180. And these are the total number of combinations which are possible, or the collections which are possible of the different books. So is this clear with all of you people? Sure? Shreya? That's good. Okay, now children, we will move on to another sum, and I'd like you people to quickly give it a try. I will give you some seconds for trial, after which I'll be discussing the sum with you people. Right. Now, let's discuss this question. We have in this question, I'd like to tell you one thing. If you'd like to try this sum a little further, then what you can do is you can pause the lecture and you can try it a little more, right? And then you can replay the lecture and look up the lecture. And do remember, have a look at the app that I've made by the name of the Mathematics Helpline, and I'm sure you will get many courses which are of your requirement. Right now children, coming back to the sum, we have a box which contains 5 different red and 6 different white balls. Right, so there are these 2 different type of balls that we have. We will register this, and here if you talk about the red balls are 5 in number, and if we talk about the white balls are 6 in number. Right, further, now you've been told in how many ways can 6 balls be selected so that there are at least 2 balls of each color. Now if there are to be 2 balls of each color, so obviously we will have to choose 2 of red and 2 of white, as 2 plus 2 4. Right, now we are just left out with 2 balls more, and they can be selected in some different ways. As if you talk about the red balls, we can take here 4 red balls, and we can talk about 2 white balls, and that will make us 4 plus 2, that is 6 balls. And then further we can have 2 red balls and 4 white balls. Again, that will also have 2 red balls, 2 white balls, and the total number of balls will also be 6. Now there can be another way that we can do this, that is we can even take 3 red balls and we can take 3 white balls. Even their sum is going to be 6 balls, and we've also taken 2 balls of every type. So these are the different forms in which we can have the different balls. But remember, why do we have a plus sign? Because there is no correspondence which is possible between each of these choices. That means when we are taking 4 red balls and 2 white balls, or when we are talking about 2 red balls and 4 white balls, there's no correspondence as such which is possible, and that is the reason why we put up a plus sign. Do remember this, that the principle of multiplication, which is what we used in the last case by putting up a multiplication sign in between, is only applied if there is some correspondence between the data. Now when we do not have any correspondence, then we put up a plus sign, because obviously that is also a valid choice that has to be taken, but incidentally there is no correspondence which is available. As such, we won't put up a multiplication sign in between. Now next children, after this we are now going to talk about each of these cases. When we talk about taking 4 red balls and 2 white balls, remember here we are talking about a choice. We are talking about a selection or we are talking about a combination, that is the order is unimportant in each of these balls which are of a different type. That means they can easily be identified to be different balls. Now when we talk about this now, then 4 balls from 5 balls can be selected in 5C4 ways, right? And 2 white balls from 6 white balls can be selected in 6C2 ways. And since each of these are going to be corresponding with each other to get the total number of balls, which are 6 in number each with every case, so as such there has to be a multiplication in between. We'll put this in a bracket because this is of one type. Now we talk about choosing 2 red balls from 5 red balls, and that can be done in 5C2 ways. And then we talk about choosing from 6 white balls 4 white balls, which can be done in 6C4 ways. And remember children, as there is correspondence which has to be done between the balls of these 2 different types, we will have to put up a multiplication sign in between. And then now we come to the third case, which obviously now in a similar way can be done in 5C3 ways. That is, 3 balls can be selected out of 5 red balls in 5C3 ways. Now 3 white balls from a group of 6 different white balls can be chosen in 6C3 ways, and then we put up a multiplication sign in between because there is correspondence which is possible. Now we've got to calculate this to get to our final answer. So for the children, we can write this as factorial 5 and divide that by 5 minus 4 factorial, and that is further going to be multiplied by factorial 4. Then we will write a multiplication sign, and then we write factorial 6 and divide it by 6 minus 2 factorial times of factorial 2, and then further to it we write a addition sign by putting all of this in bracket, as this is one group. And then we have factorial 5 and divided by 5 minus 2 factorial times of factorial 2, and then next we multiply this by factorial 6 and divide it by 6 minus 4 factorial, and then multiply this further in the denominator by factorial 4. Now to this group now we add the last, that is factorial 5 and divided by 5 minus 3 factorial times of factorial 3, and to it we multiply 6 factorial and divide by 6 minus 3 factorial times of 3 factorial. Now children, is the time to calculate all of this, and that, as you've seen, is pretty simple as you already done the basics. Now here next what we do is we can now write this as factorial 5 and divide that by factorial 1, which will remain to be 1, and further we have factorial 4 in the denominator, and to that is to be multiplied factorial 6, and in the denominator we have 6 minus 2 factorial, that is factorial 4, and to be multiplied with factorial 2, and then to it is to be added factorial 5 and divided by 5 minus 2, that is factorial 3, to be further multiplied by factorial 2, and then further multiplied by factorial 6 and divided by 6 minus 4, that is factorial 2 times of factorial 4, right? And then we further close this bracket, and to that we add here factorial 5 and divided by 5 minus 3, that is factorial 2, and multiplied by factorial 3, and to that then is multiplied 6 factorial and divided by 6 minus 3, that is factorial 3, to be further multiplied by factorial 3. Now next children, what we do is here we now solve it as factorial 5 can be written as 5 into factorial 4. So we write it that way, and in the denominator 1 factorial is the same as 1, and as 1 is multiplicative identity, it will vanish into thin air, and then we will have factorial 4 in the denominator. Factorial 4 will get cancelled, and to that is going to be multiplied factorial 6, which can be written as 6 into 5 into factorial 4, and in the denominator we have factorial 4, which is further multiplied by factorial 2, which can be written as into 2 into 1. Obviously 1 is multiplicative identity, so it will vanish. Factorial 4 will get cancelled from the numerator and from the denominator. 2 will cancel 6 3 times, and then we will put this in the bracket, and to that is going to be added factorial 5, which can be written as 5 into 4 into factorial 3, right? And in the denominator we have factorial 3, which is multiplied with factorial 2, which can be just written as 2. Next now factorial 3 will get cancelled from the numerator, and from the denominator 2 will cancel for 2 times, and then further to this is multiplied factorial 6, which can be written as 6 into 5 into factorial 4. And in the denominator we have factorial 2, which can just be written as 2, and we have factorial 4, which will cancel each other in the numerator and in the denominator. Now to this, children, is going to be added the last term, which is factorial 5. So that can be written as 5 into 4 into factorial 3. And in the denominator we have here 2 factorial, which can just be written as 2 multiplied by factorial 3. So here factorial 3 will get cancelled. 2 will cancel for 2 times, right? And then we come to the last binomial coefficient, or to the last expression of combination, and we can write that as factorial 6 to be 6 into 5 into 4 into factorial 3, and in the denominator we now have factorial 3, and with that is multiplied factorial 3, that can be written as 3 into 2 into 1, that is just 3 into 2. Now factorial 3 will get cancelled. 3 into 2 is 6, which will get cancelled with 6, right? Now is the time when we add these 3 trinomials after calculating them and get to our final answer. So the first, children, here we will get to see that we have 5, which is going to be multiplied with 5 and further to be multiplied by 3, so that will become equal to 75. So we have 75 to be the first term of this trinomial. Next, now, children, we come over to the next, which is 5 into 2, that is 10, to be further multiplied with here 6 into 5 as one term. 2 will get cancelled with 6 3 times, and thus we can calculate this as 5 into 10, which is 5 into 2, which is 10. 10 into 3 is 30. 30 into 5 is 150. So next, now we write the second term as 150, and to that, children, we add the next number, which is here 5 into 2, which will become equal to 10, and further we have 5 into 4, which is 20. So 20 into 10 will become equal to 200. So that, children, is the last term. Now we add all of these 3 terms of this trinomial, so that gives us 5 here. Then we have 5 and 7 is 12, 1 remainder. Then we have 2 and 1 is 3 and 1 is 4. So 425 will be the total number of combinations which are possible and will be your final answer. Now, children, I'll just quickly discuss all of this all over again, so that if there is any doubt withstanding, all of that will quickly fizzle off. Now, in the question, you've been given a box contains 5 different red and 6 different white balls. In how many ways can 6 balls be selected so that there are at least 2 balls of each color? So if you talk about at least, that means there has to be 2 for sure. But if it is more than 2, no problem. So here, children, what we've done is, when we talk about the first 2 cases, we have 2 white balls, right? That is the least which is possible. 2 red balls, which is again the least which is possible, and to that we are adding 2 red balls more, so that the total number of balls that we require is 6 is achieved, right? Okay, next, now 6, that is here 6 balls, right, can be achieved. Okay, this was 6 of the white balls. Now next, children, we talk about the at least 2 condition for red balls, at least 2 condition for white balls, and we can take 2 white balls more so that the total becomes 6. In the next case, we just talk about 3 red balls and 3 white balls, as when we talk about 3 red balls, the at least 2 condition satisfies for red, and the at least 2 condition also satisfies for white. So we take one more, so the total number of balls can be 6. So these are all the cases which are possible. Now, children, we talk about writing the combinations which are to be in each of these cases. When we talk about taking 4 red balls when 5 red balls are there, so we are actually wanting to find out combinations of 5 different objects when 4 are required. So that is going to become equal to 5C4. And when we talk about 2 white balls when 6 white balls are available, so that will become 6C2. Similarly, we can talk about 2 red balls from 5 red balls to be 5C2, and 4 white balls from 6 white balls to be 6C4. Similarly, 3 red balls from 5 red balls can be found out as 5c 3 ways, and 3 white balls from 6 white balls can be found out as 6c 3 ways. Now here we will be putting up a multiplication sign in between each of these as they correspond to each other. We talk about one choice and then we talk about another choice. We talk about one choice and then we also talk about the next choice which is possible for this, and thus there is correspondence among each of these 3 pairs. And then we put up a plus sign in between because each of these choices do not have any combination. That is, the first with the second does not correspond as they are different type of entities, so they won't correspond, right? Then after this, children, we will calculate each of these combination expressions like we discussed earlier. Whenever we talk about NCR, it's going to be n factorial upon n minus r factorial times of r factorial. That is 10c4 is just the same as factorial 10 divided by 10 minus 4 factorial, that is 6 factorial times of 4 factorial, right? So here we've calculated all of this in a similar way. Just one thing here, if you talk about factorial 6 which divides 6 minus 2, that is 4 factorial times of 2 factorial, here what we've done is we can write this as 6 into 5 into factorial 4, because factorial 4 obviously is 4 into 3 into 2 into 1, right? So factorial 4 can be cancelled off, right? And then 6 into 5 will get cancelled with factorial 2, which is 2, right? And then we get this to be a positive integer, right? So this is how each of these binomials have been calculated, and then they've been multiplied together to get to simple answers. Then each of these 3 terms of the trinomial have been added and the final answer comes to 425. So is all of this clear with you, children? For sure, Jabran? That's good, children. I'm sure you people must have really liked this lecture, so make sure you give a thumbs up, right? Do press the bell icon, share it with your friends, right? And for sure do visit the app, the mathematics helpline in the Play Store. I'm sure that's going to be of very much help. So bye guys, have a nice time, and do comment about which was the question that you didn't understand in permutations and combinations, and in times to come I'm going to make more lectures where I'll provide you answers to those, right? Bye for now and have a nice time. Bye.